Let's practice multiplying complex numbers together. And when we're done multiplying, we're going to make sure that we turn them into this standard form, which is just going to basically be this a plus or minus bi, where we have our real part first and then our imaginary part second. It's also maybe important to know that if you have I squared, that I squared is equal to -1. So let's keep that in mind while we are doing these as well. So for number 1, we have the quantity of 3 plus 2i times the quantity of 4 minus 3i. So we're basically just going to FOIL here. So we do 3 times 4 first. That's going to equal 12. And we'll take this 3 multiplied by this -3i. That's going to be -9i. So we can write minus 9i after. Then we'll take this 2i multiplied by 4. 2i times 4 is going to be positive 8i. So write plus 8i. And finally, this 2i times -3i. 2 times -3 is -6. I times I is I squared. So it's going to be -6i squared. All right. Now, if we take a look at these middle two terms, these are like terms. We can combine those. So -9i plus 8i is just going to be a -i or minus I. And then if we go ahead and take a look at this minus 6i squared, keep in mind that we said that I squared, that was equal to -1. So when we see this I squared here, we can turn that into a -1. So this is going to be 12 minus I minus 6 times -1. And then 6 times -1, that's going to be positive 6. So we really have 12 minus I plus 6, right? Now 12 plus 6 is going to be 18. So we can say 18 minus I. That would be our final answer written in standard form for this complex number. All right, for number 2, let's go ahead and just take the quantity of this 5 minus 3i times the quantity of 6 plus 5i. First, we're going to do 5 times 6. That's going to equal 30. So we're going to start with that. Put a 30 here. And then we're going to do 5 times this positive 5i. That's going to be positive 25i plus 25i. Then we're going to take -3i times 6. And that's going to be -18i minus 18i. And then -3i times positive 5i. That's going to be -15i squared. -15i squared. Right, so in the middle, just like with quadratics, we have two of these like terms. So let's go ahead and combine those. So 25i minus 18i, that's going to be positive 7i. And then we have this minus 15i squared afterwards. Now keep in mind we have I squared, which is equal to -1. So this is going to be 30 plus 7i minus 15 multiplied by -1. Okay, so we have a -15 times a -1, that's gonna be a positive 15, so we have 30, and then plus 7i, and then plus 15. And if we go ahead and combine the 30 and 15 together, that's gonna be 45, so we'll get 45 plus 7i. So that would be the standard form for this complex number, where a is 45 and b is equal to 7. For number 3, we have the quantity of 6 plus I times the quantity of -3 minus 2i. So multiplying 6 times -3 first, that's going to be -18. Then take this 6 and multiply by -2i. That's going to be -12i. Then it's the i's turn, so I times -3, that's going to be -3i. And finally, I times -2i, that's going to be -2i squared. Okay, now we have these two middle terms that both have I. We can combine those. So we have -18 and then -12i, take away 3i should be -15i. And then we still have this minus 2i squared that we haven't done anything with, right? Now if we have this I squared, that's -1. So really this is -18 minus 15i. And then we have what? -2 multiplied by -1. So what is -2 times -1? That's positive 2. So we have -18 minus 15i and then plus 2. Let's combine that -18 and positive 2 to make -16. So we have -16 minus 15i. And this right here would be the standard form for a complex number where a is -16 and b is -15. For number 4, we have the quantity of -4 minus 3i times the quantity of 3 plus 2i. Let's take this -4 multiplied by 3 first. That's going to be -12. Now take this -4 multiplied by positive 2i. That should be -8i. Then we'll take this -3i multiplied by 3. That's going to be -9i. And then finally, this -3i times positive 2i. That's going to be -6i squared. All right, so in the middle, we have these two terms that we can go ahead and combine, right? Just like the last few examples, we have negative 12, and then this negative 8i minus 9i is going to be negative 17i, and then we have this minus 6i squared. Now I squared is equal to negative 1, so let's take that negative 12 minus 17i, and then this is minus 6 times negative 1. Now negative 6 times negative 1 is positive 6, so really we have negative 12 minus 17i plus 6. And then negative 12 plus 6 is going to be negative 6. We have negative 6 minus 17i. This would be standard form for this complex number, and a is equal to negative 6, and b is equal to negative 17. All right, let's check out number 5. Starting off, we'll multiply 8 times 8, and that's going to be 64. We'll start with that. Then 8 times this negative 3i, that's going to be negative 24i. Okay. Next, we're going to take this 3i multiplied by 8. That's going to be positive 24i, so plus 24i. And then finally, 3i times negative 3i, that's going to be negative 9i squared. Now, if you were thinking about a difference of squares pattern, you were right, because these two middle terms are going to cancel out. So we're just going to get 64 minus 9i squared. That's a difference of squares. Now, I squared is equal to negative 1, so we can rewrite this as 64 minus 9 times negative 1. And really, that's going to turn into 64 plus 9, or the same thing as 73. So this goes ahead, and when we multiply it out, we actually realize that we just get a real number of 73. So a is 73 and b is 0 because there is 0i afterwards. In the future, if you see a difference of squares pattern with imaginary or complex numbers, then when you go ahead and multiply them or find the product, you're going to get a real number. Just like we got here, we got the number 73. For number 6, we have the quantity of 3 plus 4i times the quantity of 3 plus 4i, so we have two of the same binomials here. So this is a perfect square trinomial, or you may have seen this when you complete the square. So let's start off with 3 times 3. That's going to equal 9. And then 3 times this 4i, that's going to be a positive 12i. Then we'll take this 4i multiplied by 3. That's going to be another positive 12i, which should make sense. We should get two of the same thing. And then 4i times 4i, that's going to be positive 16i squared. Now if we go ahead and combine these two middle terms, we have this 9, and then 12i plus 12i, that's going to be 24i. And then we have plus 16i squared still. Now this I squared at the end, we know that's going to be negative 1, so we can write 9 plus 24i plus 16 times negative 1. Now 16 times negative 1 is just negative 16, so we have 9 plus 24i minus 16. And then 9 minus 16, that's going to be negative 7, so we're going to get negative 7 plus 24i. So this would be our standard form for this complex number. For number 7, we have the quantity of 5 minus 2i times the quantity of 4 minus 3i. First, we'll multiply this negative 5 times this positive 4. That's going to equal negative 20. We'll start with that. Then take this negative 5 multiplied by this negative 3i. That's going to be positive 15i. Then this negative 2i times positive 4. That's going to be negative 8i. So write minus 8i afterwards. And then negative 2i times negative 3i. That's going to be positive 6i squared. So plus 6i squared. Now in the middle, we have these two terms of 15i minus 8i, we can combine those. We have negative 20, and then this is going to be plus 7i, and then plus 6i squared. Remember, this I squared is equal to negative 1, so we can rewrite this as negative 20 plus 7i plus 6 times negative 1. And 6 times negative 1 is negative 6, so we have 20 plus 7i minus 6. Now the negative 20 and negative 6 equals negative 26, so we can rewrite this as negative 26 plus 7i. This would be the standard form for our complex number, where a is equal to negative 26 and b is equal to positive 7. Finally, for number 8, we have the quantity of 7 minus 3i times the quantity of negative 2 minus 2i. So let's take the 7 multiplied by negative 2. That's going to be negative 14. Start there. Then 7 multiplied by negative 2i, that's going to be negative 14i. So minus 14i. Then negative 3i times negative 2, that's going to be positive 6i. So plus 6i. And then this negative 3i times negative 2i, that's going to be positive 6i squared. So plus 6i squared. Now these middle two terms can be combined. So we have negative 14 in front. Then negative 14i plus 6i is going to be negative 8i. And then we have plus 6i squared at the end. I feel like I've seen a lot of 6i squareds. I don't know if I just made those by coincidence on a bunch of these. So we have negative 14 minus 8i. And then plus 6 times this negative 1. 6 times negative 1 is negative 6. We have negative 14 minus 8i minus 6. And negative 14 minus 6 is negative 20. So we have negative 20 minus 8i. So this would be the complex number written in standard form where a is equal to negative 20 and b is equal to negative 8. So there you have 8 different practice problems on multiplying these complex numbers together. Hopefully you can see that in each of these examples we could combine our middle two terms because they're like terms, so just treat the i's as variables and you can just go ahead and think about them that way. And then each time we also end up with an I squared somewhere and that's equal to negative 1. So just try and combine those constants together at the end and write the real part first, which is just the constant, and then write the I term second, which is the imaginary part. If you found this video helpful, please consider giving it a thumbs up, and as always, keep up the great work, and I'll see you in the next one.